Hey guys, and welcome to this debug break. We're going to come to you today with a problem that one of our students came to us with, a very specific problem about how to label grids based on their left to right and up to down orientation. This is obviously really important when you're setting up a project. So we're going to go through how you do that. We're going to use Grasshopper, but the underlying algorithm that we're going to use, we'll also expose that in Dynamo as well, just to show you exactly how you could use either one of these programming medium to do our job. First things first, as always, we go straight to the paper to do our little pseudocode and understand how we're going to do things. So when we look at our input process output board, let's just see here. So what do we want to do? We want to take a bunch of curves that we've drawn. In this case, we're going to say we've drawn them in Rhino. We want to take those curves and we want to have them end up being something at the end that are more like this. So we're going to copy this. They're going to look exactly the same. We're not going to change them at all. But the key is when you look on drawings typically, and this is obviously something that even architects would know, but structural engineers would definitely know, that traditionally you might see the grids represented with this type of notation. And the key thing here is the student came to us and said, I want it to be numbered 1, 2, 3, A, B, C, D, E. Okay, so this student has come to us and he's asked us, hey, listen, I want it to look right. I have generated these grids. This lesson is not about how you generate the grids. That's parametric design. This is computational engineering. It's really about processing those curves to make them into something that is effectively grids. What makes them grids in this case is that underlying logic that we're giving it as part of what I've just sketched here. So let's think about that a bit here. How would we go about actually doing something like that? So one of the things there is we could see logically here that actually one of the key things is there's a huge distinction between verticals and horizontals. Or at least, let's be very specific, there's two orthogonal directions. So it could be that these aren't necessarily vertical and horizontal on the page or relative to another datum, but there's two orthogonal directions. So that's definitely in our future. So when we sketch this out, we already know that this input is eventually going to have to go to some sort of dispatch. We know that from day one, that there's going to be a dispatch, and from that dispatch, we are going to have to, at the back of it, you're going to have certain curves that are orthogonal in one direction. So orthogonal direction 1, and in the other direction, you would have orthogonal direction 2. Okay? Now, we're going to start high level, and then we're going to figure out how we make this into a bona fide real pseudocode here. And then once we have it in there, then it's really just an issue of, okay, in 1, we'd have to generate a series of numbers. Yeah, so for one, we're just going to generate a series of numbers that goes from 0, 1, 2, 3, 4. So that 0 to 4. And in the other case, and I think I've got it backwards here. Yes, I have. So it's not numbers on this one. It's A, B, C, D, E. So I'm just going to move down these numbers. The numbers are for down here. And this one's A to E. And this one's series of letters. Okay, so that's step number 1 here. That's going to be the last step here when we talk about it. So first step number 1, we know, let's get these two separated out. And number 2, once we do that, let's be inspired by how many curves are in each one, and let's separate them into a whole bunch of different categories. And then effectively, we would be able to say, okay, these curves, if we had something like the bomb or some other sort of plugin that said there's a grid item that takes in the name and takes in a curve and spits you out a grid, we'd be able to do that. Okay, so we understand effectively here that a grid is no more than just the name of a grid as well as the centerline curve of a grid, and that comes over here. So that's the underlying algorithm that we're going to get into here. And as part of this, we're going to be able to get into some fun, kind of typical, in my mind, engineering filtration. One of the key filtration techniques, if you follow us at computationalengineer.com, some of our key core skills, one of them is filtration. And in this lesson, you're going to see a key filtration technique that, in this case, I'm going to recommend we use the DotProduct. So we're going to show you how to do that. And then effectively, we're going to get into a bit of numerical and series manipulation. This is more going to be over on this side of things, list manipulation. And that's it. So let's jump into that first on a one building level. And then we're going to show you how you would scale that up effectively when you have multiple buildings. But first, let's start how you would do this if you just had one set of grids. So let's go back to the computer now. We have our first principles done. Now we're able to go follow our logic into the computer. We're ready to code. So first things first, let's create some curves that represent grids here in Rhino. Okay, so I'm going to turn on orthogonal down here, and we're just going to copy this a few times. Again, we're not looking for precision here. We're just looking for something that kind of matches what I've drawn there, and we'll do it in the other direction as well. And I'm literally going to do just something weird like that. Okay, so there is exactly what we had on paper. Now, as we move forward here, we need to go over to Grasshopper, and we're going to reference these in. So again, we could absolutely just say these are this way and these are this way. But in this particular case, this student has asked how we do this on a grand scale. There's about 100 buildings that this student wants to do relatively quickly and multiple times. So it's something that they really just want to grab all of the curves that represent the grids and do this operation for. So if you're asking yourself now, why don't I just reference in like this, curve, right click, set multiple curves, and then do the same thing. Which ones did I just grab? So I just grabbed we're in green mode, so I just grabbed some verticals, but not all of them. So set multiple curves, and then we'll do the same thing, but for the verticals, for the horizontals rather. Set multiple curves. You could say, there you go, and now that first part of the script that you were talking about is, sort of completely irrelevant. So why are we doing this? And again, when we want to scale something like this up and do it with multiple buildings at a time, that's going to be a little bit more of a pain to have to select all of that. So that's why we're doing it this way. So we're going to go ahead and and the other thing is it's just fun to let the computer do some selecting for you. That's what filtration's all about. Half of our lives, we're sitting here and we are clicking and clacking things and selecting things. If you can teach the computer how to click things for you, your job becomes a lot easier, and you can spend your time being creative as opposed to just being a robot. So that's what we're doing here today. Don't choose to click things. Let the computer click for you. All right, guys, so let's do this. So you can see here we got the curves referenced in, and we're ready to get rocking and rolling. So we had said, let's just kind of bring that to the table here. We had said there's a dispatch in our future. So there's a dispatch here. And we also said then there's some generation of names. So let's be clean. And let's just say these are the input curves. All right, let's do the dispatch. Now, I said to you, we have a bunch of curves here, and we want to convert them into two sets of curves. So one set of curves becomes two sets of curves. And the two sets of curves are differentiated by their direction, their orthogonality. Now, in this case, I'm going to show you the easy way. If we want to get into a more advanced situation, please let me know in the comments below if you want to see how you would do this. If it wasn't the case that the grids that I've just drawn here, you notice they're orthogonal to the world coordinate system, all right? So if you want to understand more about how you would do this if it wasn't the case, if it was more like, where's my gumball? If it was more like this, it's on orthogonal, can't do that. If it was like this, how you would do it, we can do that. But let's stay simple here. How would we do it in this case? How could we differentiate? What's one rule we could do to differentiate the ones that look to us vertical on the screen and the ones that are horizontal? Let's keep one thing in mind. There is no reason to think whatsoever that the computer thinks that the first three here are these ones are the first three and these ones are the last four. There's no real logic to that. We can't assume that the computer says the order of these is 1, 2, 3, 4. Just to show you, and I'm not sure this is going to be the best example, but let's see. So if I go and I say, let's pull out a nice little thing called point on curve. We just want to throw some tags out there. And then I'm going to go point list. So this point list, effectively, if I go green mode here, green mode is the best mode to be in when you're debugging. If I click these curves, I got the centroids of those curves. And now this points component here, that one's helping us. We're in millimeters, so I'll say 1,000. I don't know what scale those are drawn at, but you get the picture. Boom, crazy. Okay, let's bring it down a bit. Wonk. Okay, so you can see here the logic of, 0, 1, 2, 4, 3, right? And then 5, 6, 7. So some of you might say, well, we could just try and figure out how many, even in this case, how would you do it if it was just based on ordering? You would have to say it always has to be 5 vertical and 3 horizontal, and then maybe we could split it after the 5th index of the list. But effectively, this computer does not see the same picture that we see. It doesn't see a grid system. You impose that with your mind. It sees 8 curves, and it goes 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. So we really can't bank on anything from a list perspective to understand which ones are orthogonal and which ones not. It needs to be a geometrical dispatch. It needs to be a geometrical rule. So we need to translate into the computer what is it that our brain is doing when we see this grid and we interpolate it as a grid in 2 orthogonal directions. So that's what we're going to do right now. We're going to use something called the dot product. Now, for those of you who aren't really mathematically inclined, I don't know if there are any engineers who are not mathematically inclined, but you can look up a little bit about the dot product. But you can see here in the emoji of the dot product that Grasshopper has here, it really is a function that deals with angles between 2 vectors. So effectively, all you need to know in this case is the dot product is a brilliant dispatcher, because what it does is it will return for us 0 or 1, which, if you know computation, that's true or false, which is the basis of a dispatch, true or false. Which way am I dispatching the data? So effectively, that is a huge thing, because it takes 2 vectors and it gives 0 or 1. So if 2 vectors, I always forget which one it is. If 2 vectors are parallel, it's 0. If 2 vectors are orthogonal, it's false, or it's 1, right? So that is a key thing for us, because it will allow us to effectively embed that logic of some of the horizontals go this way, some of the horizontals, the verticals go this way. And because we're orthogonal to the world coordinate system, we're going to go ahead and use the world coordinate system to our advantage. So we're going to take the dot product of these input curves, and we're going to bring out a unit y. So if we take out a quick panel here, and we look at a quick panel, we will see zeros. We can actually see the logic because we know what the order is. We saw before 0 to 4 is the verticals and 5 to 7 is the horizontals. Now, the key here is, I had said before, zeros and ones. It could be zeros and negative ones, by the way. So what we're going to do is we're just going to throw an absolute value in here. Because where we're headed here, we said it was a dispatch. I might be speaking Grasshopper language here because Grasshopper language matches my English. But really, when I think of dispatch, I think I have this list of stuff, and I go through this funnel that basically says, pushes you one way or another, effectively. I want some of you go to the left, some of you go to the right. And that's exactly what dispatch in Grasshopper does, and it's one of the quintessential filtration tools. And it's perfect for our application right here. Because what it's going to do is it's going to take this input curves. So filtration, if you have done our lessons on filtration, filtration is I have a set of data and I want to do some selection of it, subsetting of it, dispatching of it, or segregating of it, you know, splitting it into two like we're doing it here. I have the input data. I have something that generates metrics about that data, and then I go over the top like that to my logic, my Boolean logic or my selection logic. And then that's it. We use that selection logic, and what comes out the back side here. So I'm going to do curve. We're going to do a nice little bucket. You see here in green mode, boom. I'm going to go ahead and turn off the layer that we drew that on, just so we're seeing clean slate here. So boom, we went from this to this. So that is verticals. And you know what the other one's going to be. It's the horizontals. Now, forever and ever and ever, if you use this script, you have grids that are orthogonal to the local coordinate system. Boom, done. You have a dispatch happening here. So that is done. That was the first part of our script. Congratulations. We are well on our way. And you know what? I'm just going to make this nice and clean here. We're going to just make it a completely nice little cluster here, or group rather. And now we're going to go ahead and we're going to generate some names for these guys. So here we go. So this is a quintessential. I have a bunch of curves and I need an equal number of, there's two things here that we actually have to do. We actually have to think about this from a perspective of I need an equal, first things first, I need an equal number of either numbers or letters. So let's go over that first. So let's try with the verticals first. So first thing we're going to do is, first thing, Grasshopper, we need to know how many curves do we have here. So that's a list length. So list length, boom, done. That's 5, right? And if you know anything, we said the first one was a series of letters, right? So what I'm going to do in this case is I'm just going to create a panel, and I'm just going to create a multi-line data panel, and I'm just going to create some letters, A, B, C, D, A, B, C, C, D, E, F, G. You know the alphabet. And effectively what I'm going to do is I'm going to use our good friend series, and I'm going to go from 0 to 5. So let's see here. How many things do I have? I have 5 total. So series creates a series of numbers. The starting point of this, I think, is 0 because 0 is A. But if we go up to 5, that'll be too much. The computer, we don't want that. So what we're going to do is, this is the count. This is the end of the series. So right now I've created a series of numbers from 0 to 4. And actually that is the correct. That's 5 numbers. And what we're going to do here, list item, is list item. If you watch any of our tutorials, it is one of the most quintessential things. It is selecting one thing out of a list. So it asks you for a list. In this case, we want a list of letters, and it asks you for a list of indices. So out of that list of the alphabet, I didn't put in the entire alphabet, but you hopefully can see that if I did, effectively, we'd only be picking out of the alphabet A, B, C, D, E. You can see here F doesn't come through because the script is choosing for us how many letters we need based on how many different values that we've put in for the verticals. And series is our best friend when it comes to stuff like this. So this logic, this type of logic, is in a lot of more advanced scripts where you're just trying to say, listen, I'm embedding this logic that I see on the page. And then you can imagine what we're going to do next. Horizontal is very easy as well. So the next thing we're going to do is, do the exact same thing. We're going to copy this guy, and you could probably imagine at this point we're done, right? We don't need to do letters. It's 0, 1, 2. Now anybody who's in the industry will know, and if we go back to our sketch, we don't do 0, 1, 2. We count from 1 because we're humans, not computers. And there you go. That's it, boys and girls. That's all she wrote. I'm just going to go ahead and let's use our data bucket. Oh, those are curves. So let's use a data bucket here real quick. Let's call this one vertical names. Let's keep our script nice and tight here. And let's get going on H names, horizontal names. Ladies and gents, here comes the end, right? Let's go ahead and cluster that up. Okay, so let's do a test, right? So we had said we now have vertical names, and we now have vertical curves and horizontal curves, right? So we're just going to take that stuff around. Clean scripting as always here on the Computational Engineer. So for our students, one of the things that we always teach is let's visualize things. Let's try and understand, did this work, right? So before, we had showed a methodology of how you could actually demonstrate visually, what the computer is thinking in terms of order. So when we were on paper over here, we drew a bit of a sketch that was actually sort of showing how we would think of things in real world, right? So what I'm going to do is just quickly try and visualize what we've ended up with here without going to Revit or anything else like that. So let's do it. Let's get the start points, or end points as they call them in Grasshopper, of the verticals. And let's go ahead and use my favorite component, the tag component. This is one that lets you visualize data, baby. Let's put that in. It takes in a location, and it takes in some other text, and it puts on a label. And lo and behold, right there, right then and there, A, B, C, E, D. Uh-oh. A, B, C, E, D. What did we do wrong? I almost gave it away earlier. I'm intentionally trying to make a mistake on this one because, as you know, computation is all about debugging. It's about making mistakes. I actually like to make some sort of mistakes because I had this happen before many times, and if I do it perfectly, you'll think that, oh, it's easy. It's never easy. The things always turn red. They always turn orange. They always don't work. But it's the key of this is just, let's try and figure it out. Let's solve it. And eventually you solve enough problems, they'll all go away. So what did we do wrong in this case? What did we leave off? Well, we left off one really important thing while we were on paper. So let's go back to paper. What we can see on the screen is that we neglected one major thing that we embedded within this rule set, but we did not actually follow through on, is the fact that, and I think at one point I might have drawn it, is that there is a logic top to bottom, left to right. Top to bottom, left to right. And nowhere in this script did we take responsibility for that. Nowhere in this definition is there responsibility, and we should have known it right when I was showing you that the computer does not have that that order implied. The computer, at the beginning of the tutorial, we had shown, it does not know that that was going on, and it was labeling things as it is right now, A, B, C, E, D. So we need to necessarily, somewhere in here, we need to have a sorting function of those lines. So that's what we're going to do. We're going to splice into this algorithm something that sorts those lines such that they come out the backside in the right order. The right order is the order that would match for us those things that we had just put in the output. And then we're there. So how can we do that? And this is, again, another quintessential type of filtration or data massaging exercise. And that is, again, we need to take effectively, and why don't we just stay on paper here, how would you take a list of lines and convert them? So let's just take a sub-algorithm here. And again, what's our situation? List of lines. Honestly, we don't care if they're this way or that way, right? We just care that they're parallel. But we do know we have two different situations, and how would that manifest itself? So what I would typically do in this situation is, what I'd be looking to do is I'd be looking to, because we are orthogonal to the world coordinate system, I'd be looking to say, okay, great, take those lines and find their center points. And then I want to take those center points and I want to convert those center points to, and again, I'll just draw the world coordinate system here, X and Y. So in this case, I want to convert them to X1, X2, X3, X4, X5. And then I want to sort them. And synchronously, here's the big thing, synchronously, I want to sort those curves. And out the back of it, I will guaranteed have 5 curves that are sorted from left to right. Again, this gets a bit more tricky, a bit more advanced. We can talk about this in another lesson if you want. Let me know if it's off kilter, but there's always a solution with this kind of stuff. This is an ordering algorithm, and this is one of the most simple ones that you could have. So we're going to stay simple here in this this lecture on behalf of the student who had this issue. So let's do it. So let's splice it in right here, yeah? It looks like a perfect place to do that. So let's put that over here. I'm going to put horizontals over here too, yeah? Okay, so how would we do this? So the verticals, look at our green mode, there's our verticals. We said we're going to get point on curve. Let me borrow point on curve. Did we use it? Or no, we got rid of it. Just getting lazy to type. Point on curve. Right, oh. Verticals, boom, how you doing? And then we said we want to get the X values out of each one of these. So that's deconstruct in Grasshopper. You deconstruct a point. And there's our X's. We said sort. Sort is the big guy. Sort is the massive, massive guy. And then finally, over the top, we're going to synchronously sort. This second value, we're going to synchronously sort the curves. And look, we can even put other things in there. So I'll just show you. We can synchronously sort the points. So I showed you the trick before, the point, the point list component, right? 0, 1, 4, 0, 1, 2, 4, 3 versus 0, 1, 2, 3, 4. How you doing? Right? And again, if we take these curves which come out at index A, these curves which come out at index A, convert them to points, we have the same thing. Again, these are just tools. Points and tag, they're both microcosms of the same thing. They're both things that help us see what the computer is thinking. And of course, in this case, we've solved our problem for the verticals. One big bug there. Did anybody notice that? Is I just screwed up. I put in the curves into vertical names. So we're going to undo that. What I wanted to do was I wanted to do this, rather. Verticals. Done. You know what's coming next. We're doing the exact same thing. I'm going to get rid of this B. It's kind of confusing to me. And we're just going to take this down. This is some quintessential scripting here, boys and girls. If you're an aspiring computational engineer, this is some really basic stuff that you can practice. It's tremendously valuable. It helps you become a better visual engineer. It helps you understand things. It helps you explain your logic. I keep screwing this up. And there you go. So what did I do here? 5 and 1, 2, 3. So somewhere, yep. So that's our lesson today. I hope that you enjoyed going through this problem. The student that we had on this one was in a real bind, and this was part of a bigger workflow. But I really wanted to share this with you today because this is a really important workflow. Hit us up, computationalengineer.com. We're coming out with new lessons every day, and we're always looking for your bugs to squash them. So thank you for joining us here for this bug debrief, and the debugging session, I hope, is very useful for you and your work. And we look forward to seeing you at the next session. Thanks a lot.